Welcome to the first lesson of Advanced Swift with Bob the Developer. So far, you've learned how to apply generics with functions, classes, structs, and enums. In this lesson, you will learn how to add generics within generics. You'll also understand the meaning of indirect enums using the binary tree data structure. Let's begin. Welcome to Learn Swift with Bob. Welcome to the very first lesson of Chapter 10, Advanced Swift. You're becoming more advanced. And here comes nested generics as well as recursive enum. Here's a problem statement. How to create nested generic enum as well as learn how to learn more about recursive enum with binary tree. So there are a lot of big words out here. Nested generics enum, and also learning about binary tree. It's one of the data structure. If you're not comfortable with data structure, you don't have a computer science degree, this might be tough, but I'm going to walk you through slowly. And you're talking about recursive enum back then, a little bit about when you're talking about indirect, but we're going to talk about what's really going on underneath. I said I'm going to come back to this in this chapter, and you're going to learn more about this. It's all about reference type versus value type. Well, let's move on to the first one. Learn how to create nested generic enum. Okay, cool. But why do we use them in the first place? Well, it's always important for you to take a look at your past. Always appreciate what was done in the past to understand why they'd implement something in the future, right? So let's take a look at your past. So this is before Swift 3.1 came along. Let's create just a simple model. Create generic enum. So you create two generic enum. One is gadgets with T in it. So you're telling that, hey, this generic enum must be generic, as well as because when you're working with associate type others, you want to enter some sort of value to it. For company, it could be T and as well as a T. The rest is the same. And now we're gonna make a product. Okay, design a product. And what the product does is that it contains this company, what do you call that? Property or the associate with a T value, because you have to do it because you know the company's generic enum gadgets as well as T right here, and reviews the T reviews probably going to be written in string value, so the rest can be string as well, unless you're working with the aliens. They use some sort of numbers to communicate. Well, then you cannot do anything about that. So if you want to initialize it with your own custom initialization besides what they provide when you're working with struct, enter company, enter gadgets, review company. You get the point. You know what to do about this. So here's a problem statement. It seems like we are repeating ourselves. Well, let's make a product first. Create an object like this. Boom, my product. You choose Apple, and you choose a gadget as fridge, because Apple likes to make fridge, right? If you don't believe me, just do some research. You'll find out they do make fridge. And enter review, good, silver, but expensive. Okay, so right now, if you enter this, there is a chapter 1, lesson 1 fundamentals going on all over in this place. Right now, the T is being inferred based on what? Based on good, silver, but expensive. This is the string value. So the rest of T is actually being defined. T, this must be string, so the rest also be string. So you can only work associate value of company, and gadget must be string value as well. So everything is being inferred. Okay? Chapter 1, lesson 1. I love that principle. The most important principle that most people don't care about. Here we go. Yeah, that's all good, but here's a problem statement. There are too many T's out here, so let's count the number of T's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, there are 11 T's out here. This is not good. You're repeating yourself. You are becoming a code monkey. Not really a code monkey in this case. You're just literally repeating yourself a lot, using the word T out there. But you know that you're using one T, which is a string value in this case. Well, how to go about this? Well, that's why since Swift 3.1, they came up with an amazing API. Again, API is code written by someone else. Do something like this. So let's dissect this code. So we have a team struct, okay? Team struct is apparently generic struct, and then within here we have a struct also. That means you are able to do team member, right? You're gonna go like a nested structure, and then and you didn't have to define the whether it is generic or not, but you are simply using the t value of this. So what's happening is the team member is being inferred that this must be generic because you're using t. And where is t coming from? Well, t is coming from the top, which is the team here. Okay, so we call it generic nested generics. So this team member, you don't have to specify this is generic. It's being inferred as long as you use t up here. Okay, and then where does t coming from? T coming from the very top level, which is team in this case. So let's apply that. Let's apply how we can make things more neat in our case. So let's call it. We're gonna use the same example, nested product, and then we're gonna have a couple things out here. So first one is within here. We're gonna define it here. We're gonna call it enum. If you want to clean this code up, organize right there, boom. Control I. My finger knows. I don't exactly know my finger knows. Muscle memorize everything, just like playing the piano and guitar. Enum company, you have a smartphone. So now the T is being inferred. This gadget and in company are also being known as generic, because you can tell that this, since you're using T, the T coming from the top level is being inferred based on that. Okay, so you don't really have to find T all the time like that. So here we go. So the only thing you have to do is you don't have to specify this is like, there we go. Copy and paste. Love copy and paste. Save your time. Here we go. Company and gadget. You don't see that. You don't have. You probably it's possible for you to do that like this, but you probably don't have to do that. And you. Okay, you cannot do that. Well, you don't do that. Okay, because okay, you cannot do that. Okay, so as long as if you're a little confused about that, just click on it. You'll see that, oh, nested product T is company. Okay, this must be generic. Okay, all good. And that's it. You don't really, you don't have to memorize anything. Just understand the fundamentals, and the rest will take care of himself. Here we go. Enter company, enter gadget, review, company equals enter company. You get the point. The only thing you have to define in this case is the T of the nested product, and the rest will take care of itself. Okay, so you just have to define what the T is in this case. So here we go. Let's try that. Wait. Let's see. We have 1, count 2, 3, 4, and 5. Let's compare with the top here. 1. We counted before. It was 11, and as you can tell, these are amazing. This nested, especially working with enum, you definitely you want to use nested. If you're working with associate type as well as you are working with enum, nested generic really helps you clean up the code. So now let's try to create an object, nested product, and you're still able to pick and choose. Apple, enter gadget, laptop, and enter review. Good. Okay, so everything should be fine. The rest should take care of itself. But here's the problem statement: generic cache. I think this seems like a memory pointer, address of the memory, and cyclic metadata dependency detected aborting. So what could be that possible problem with that manner? Why is that happening? Okay, I'm gonna give you 3 seconds to answer that question. 1, 2, 3. Good. Okay, if you came up with an idea, then you are BSing yourself. If your idea is also BS, but there's no answer to this. So this is what you do. The only thing you have to do is, if you see some strange things like this, besides Swift error, this is Swift error, but this is just out of nowhere. What you do is, you go to Stack Overflow, okay, and you start asking questions. Hey, Swift 3.1, nested generic bug with cyclic metadata. And then somebody's using the same example, nested product, gadget, company. Seems like somebody using the same product. Maybe a copy out from this guy. Let's take a look at it. He's exactly doing the same thing over here, but let's find out. Okay, I have no idea why this occurs. Could you please help me, please? Thank you. Let's take a look at the author. This is Bob Lee, written in April 13, 2016. This is me. So, are you the Bob Lee? Yeah, I go by Bob the Developer. Thanks, Mr. Vista, about that. I'm the real Bob. So yeah, so what you do is ask questions of Stack Overflow, and he came up with an amazing answer. He said that, by the way, this is the one I was working to prepare for this course, and I encountered this problem while making this course. And he said, hey, he came up with an amazing idea, use indirect enum, and he said he was able to circumvent. I like the word circumvent, right? Go around. This was a SAT, one of the college admission word I have to learn. And I realized he came up with this is a well-known issue. So I clicked on it. Boom, problem with struct nested generic crashes because of sickly metadata dependency. And this is literally a bug of Swift. And as you can tell, Swift is a software written by humans. And as you know, software is written in C++. That means software means there could be a bug. So it's not a big surprise. So that's why he tried to do something with enum as well as associate type. Yeah, definitely he's getting an error as well. So it says resolve for some reason, but to be honest, it's not being resolved. At least in Playground 4, Swift 4 with Playground Xcode 9, it's not being resolved. There's other problems like this, similar problems like this. So it's not being resolved, but definitely in theory it should work. This is simply a bug. So what do we do about this? Well, there's nothing we can do about this. So sometimes when Swift complains, then we just kind of follow the rule, and then again, there are many ways to solve this problem, right? We can use struct, we don't really have to use the enum in this case as well. So as long as you know the many other ways, you can just go around with different routes, and it's not a big problem for me. It's just different way. By the way, for those who never heard about cyclic dependency, which I never heard about before, I came up with definition. I researched some definition of it. So cyclic dependency is a relationship between two or more modules library which either directly, indirectly depend on each other to function properly. Well, so basically it means it's like your eyes and your heart. So you definitely need your eyes. If you want to use your eyes, you definitely need your heart. Without your heart, you cannot use your eyes, right? You cannot see something without your heart. You'd be dead. The eyes have no blood flowing going on. You'd be frozen. It'd be just hard enough, very hard, not squishy enough. Yeah, same thing. Something like that. Same kind of principle. You need one, for the other to function. So I guess there's something problem with that, which I have no idea what the heck those are. Let's read the rest. The tight coupling of mutually dependent modules. Mutually dependent. They're intertwined, which reduces making possible to separate the reuse of a single module. So when you're making a library, you definitely want to work one. We call it abstraction. You want this and this to kind of do not work together so that you can use this code, 1,000 lines of code, and on something else. You want to use this code somewhere else if you want to potentially. You don't want to when you make a library, you definitely want to make things more scalable. And the one way to do this is to remove dependencies. Here we go. So that's what cyclic dependency is, which I have no idea what the heck's going on. But now, one way for shout out to the guy. I believe his name was let's take a look at his name. Thanks to Mr. Pale. Go follow this guy. I'm not really active on Stack Overflow. Yeah, top 3%. Thank you for your answer. Go follow his troll. Okay, you love troll lol. Okay, I didn't know about that. Okay, just follow this guy. Thanks for that. I guess you love troll, huh? Okay, so we can go solve that problem by going indirect. Okay, that was a good laugh. I usually try to prepare everything I had, but I didn't see his Twitter account before, so it's just funny. So what makes indirect enum different from normal enum? That is an important part of this lesson. That is in fact the second objective of this lesson. Learn about recursive enum with binary tree. Well, let's talk about. So we covered the first objective in this lesson. We learned about why we use nested generic enum, and let's talk about recursive enum. This is more like a theoretical aspect, but it really helps you understand how enums work. Well, let's begin. Seems like my mouse is not working properly. It's not working that well. Well, that's okay. Well, so it's all about reference type versus value type. within associative value. Well, it may not make sense right now. I'm just throwing out some couple words out here, but let's discover. So first of all, I'm going to create a couple blueprints. One is class, one is struct, one is the enum, and I'm going to create an object out of them. Okay, this object will be the associative value of an enum that I'm going to create. So again, we're talking about enum. I'm going to create an enum, and then I'm going to create enum called, let's call it Bobby enum. Oh, by the way, if you've never done this before, when you're using Xcode, you don't want to do things like this. You don't want to do things like this in Xcode. Okay, you don't want to waste your time. What you do is, boom, right there. You did it at once. Okay, I've made a article about shortcuts. So learn about shortcuts. When you delete an item, you want to delete things like that. You don't want to use. I mean, I gave a talk at a conference about Xcode shortcuts, so I'm very familiar with the shortcuts. But you definitely want to use all the shortcuts. Go here, go to key bindings and do some research here. And if you want to add your own, you just go here, just make your own key type here. Okay, you can customize it. All good. So what's happening? We create an enum here, and they have associative value within, have my class, my struct, and my enum. And then when you're making an object, oh, it's loud up there. You've added this Bob class above into this object here, Bob struct here, here, and my enum here. So it's like literally happening. You're just simply using a bunch of different objects with the associative value. Okay. Well, let's take a look at what's really happening in this case. We cover how reference versus value type works in struct in classes. We haven't talked about enums. Well, we have a Bobby enum, and it contains what? It contains a case called my class, and then this my class has an associative value, and the object has a reference to this object. Okay. Well, the red here says reference on the bottom here, so it has a reference to that Bob class. Okay. So that means when you have many objects can have references to Bob class, and then when you try to manipulate that object within Bob, let's say we have different enums, enum, Bobby enum, Rob enum, and then they will have a reference to Bob class. That means when you change something from Bobby enum, there's a change in there will be a change to Bob class, and the change will be has also same effect on the Rob class. We talked about it in chapter 1, right? But for struct, however, what's happening is when you're using struct, Bobby enum has a case my struct, you're simply storing Bob struct here. Okay, you're simply storing that Bob struct within that case associative value. And same thing happens with your enum as well. When you're using Bobby enum, that case enum, my enum has an associative value of an enum type, and it simply has direct storage with the enum type. Okay, that's what's happening. Am I making sense? That's why we call enums are reference type. Enums are value types because, it just has this associative value has a direct access. Just contains that Bob case object here. My struct as well. The my struct case has that Bob struct object just holding on to it. Okay. That's what I mean by value types in this case. So what makes, okay, so you get the understanding of enum value type. However, you might thinking, okay, so what is indirect then? Why do we even talk about indirect in the first place? What makes just normal enum different from indirect enum? Well, in order to explain that, this lesson is a little tough. I have to admit, this lesson can be a little tough, but in order to understand recursive enum, it's important, it's nice to go along by learning about binary tree. So let's talk about binary tree. So let's learn about meaning of indirect with binary tree. So we have, if you've never seen binary tree, it's nothing more than, it's a data structure, one of data structure. It looks like this. Okay, enum tree, you have let's say you have an object of 3, it's a tree on the left side, tree on the right side. There's no tree on the left side and right side. 4 has a tree on the left side and right side. It can go infinite, okay? But let's talk about why this is useful, potentially useful. So we have a tree here, enum tree, and then one is empty case, and the other one is not with associative value. And if you didn't know before, associative value can have multiple values associated. We talked about with the what do you call it, barcode. We had the UPC barcode, right? Value left, right. Here we go. We have a value left and right. Okay, so let's try to create tree 1. Okay, tree 1, tree node. But by the way, why do we need to use indirect in the first place? Well, if you think about this, you're using its own type within the case itself, so that's why you have to use indirect. We'll talk about more about that soon. So tree.node, you create an object. Yeah, you can create an object. You can create an empty tree like this, but also create just an object like this way. Create a node. Value 1, and the left side is empty, the right is empty. So what's happening right now is you're starting off like this. Okay, you're starting off like that. And then let's try to create tree 2, the value 2. The left is empty, the right is empty. So here now we have here. So we create one tree on the left side, one tree on the right side. Okay, value 2, value 1. And then let's create a tree number 3, value of 3, I believe. And then he has a tree. Oh, my bad. Let me just copy the wrong one. Tree number 3. Well, tree, the value of 3, and tree has the left side 1. Tree has a tree 1 on the left side, tree 2 on the right side. So what's happening is it's happening something like this. Right there. Okay? So 3 has a node on the left side, right? If you think about tree 1, this is an object, and tree 2 on the right side. Okay? Let's create tree 4, and node 4, tree on the left side, and the right is empty. So what's happening is something like this, right there. You see, you get the point? And then what's happening is you can do some sort of cool stuff with them. If you remember correctly, with recursive operation with multiplication, and we've done it before, what you can do is you can do something like this. This lesson can be a little tough for those who are not comfortable with recursive, as well as those who are not comfortable with cases. But you have to understand. It just takes a lot of time for you to understand this. But let me try this. So evaluate tree. So you're gonna enter tree here. So we have an object, and so return int. So let's try to let's say when you're working with 3. What you want to do is you want to add all the values 1, 2, 3. So you get 6. When you're working with 4, you want to get 3. 4 plus 3 plus 1 plus 2, you get 10, something like that. So you want to add all the value that are underneath that tree. How to do that? Well, this is how you go about this. So we have a tree here, empty. If it's empty, right? If it's empty, just return 0. So yeah, it's possible because we can have a tree.empty case that will be possible. So when you evaluate tree, and then if you do empty here, it's going to return 0. Okay, it's not going to return anything on the right side. If you take a look at 0, but if you enter some sort of node, okay, case node, in value of value 1, and then let's try to add evaluate tree, and then let's enter tree 1. So if you enter tree 1, what's happening is you are using the tree node case, and it contains a value of 1. So that value becomes right now becomes 1, and you evaluate the tree of left. If you think about tree of left, it's also case enum type of empty. And when you enter left, if you empty here, it returns 0. So 1 plus 0 plus 0 returns 1 in this case. Okay. Same thing applies with number 2. Let's take a look at tree number 2 here. So if you look at number 2 here, the value, you're entering the value. The value, because 2, is simply return 2. The left side is empty. Okay, it returns, if it's empty, you know that the value tree, it goes through empty case here, it returns 0. So the rest is the same. And if you work with number 3, however, a little interesting stuff happens. Tree 3. It becomes 6. Why is that so? Well, you have to think about it this way. It can be a little tough, but again, it requires you to think a little more. So if you think about 3, you enter evaluate tree 3 here. In this case, you're entering the value of 3. tree 3 here, and in this case, the case will be the node here, right? The first case will be that, and then you get the value. So the value will become 3 in the first place, right? Because tree 3 has a value of 3. However, if you think about left, it also contains what? It also contains tree 1. And then if you remember correctly from tree 1, it goes through tree 1, evaluate 3, evaluate tree 1 comes up, and what is a tree 1? It has a value. It goes to the node, the value 1, the left is 0, the right is 0, so it returns 1. So this entire thing returns 1. And if this is right from the perspective of 3, it is true. So you get the point. I mean, if it's confusing you, you just have to kind of read through it. If you have a decent amount of IQ, you should be able to understand. Just follow along the steps, okay? If you have any questions, comment down below. But we haven't answered the question yet. What makes indirect different from normal enum? This is the important part of we haven't talked about this. Well, this is important, but I'm not sure if I can explain this better. I'm not sure if I can explain this good enough, but I'll try. Okay. So right now, if we talked about it before, we talked about it. Enum, when you're working enum in this case, I said enum contains the case associative value. So for example, if you're working with that, if it's normal enum, what happens is this thing here will be like this, combined into some sort of it's combined here, something like that. That's what I mean by enums, right? That's why normal enum. Everything is combined within that same enum. However, when you're using indirect, what's happening is rather than having its own enum associated, it's actually referencing the other. Okay, that's why you see this red arrow here sign. This is literally referencing each other. Okay, again, if it's normal enum, you contain all the value, associative value within yourself. But if it's indirect, it has a reference to the other, So I guess when he said here, he said. However, we are able to circumvent this, making enum as indirect. This will store associative value in another place, which breaks the cyclic dependency. I don't exactly know how this thing together work, but what he's saying is that when you make these things indirect, what's happening is the associative value is not being stored directly within that enum. The associative value is being stored, created in another place, and that associative value has a reference to that thing. Okay, am I making sense? I may not make sense. Again, but I don't exactly know how the indirect helps with cyclic dependency. However, in this lesson, we learn what makes indirect enum different from normal enum. Again, indirect has a reference to one or the other. One object has an indirect, one object reference. But if it's direct, if it's normal enum, you know that associative value has all the value within that single object, but indirect reference pointing at each other. Okay, it was a long lesson, right? It was a long lesson, but hopefully you guys learned something new with me. I hope you guys, it was a long lesson because you have to talk about the binary tree as well as there's a big stuff out here. Keep learning. Thanks for sticking with me, and I will see you in the next lesson. First, you've learned how to design beautiful code by learning about nested generics. Second, you've learned the difference between normal enum versus indirect enum when it comes to associative value. Please remember, indirect enum behave like classes. They point rather than store directly. Some may feel baffled by the recursive function that we use to calculate the value of node. Well, I recommend you start from the very bottom and slowly build the way up. The next lesson, you will learn how to create your own custom operators. Let's begin.